Do questions like these intimidate you? Want to learn the skills necessary to master answering questions like these? Stay tuned because we're going to take a complete look at quadratics from beginning to end with today's masterclass. Welcome to Mastering Mathematics, the Quadratics Masterclass. Hey everyone, and welcome to our first session on quadratics. In this particular video, we're going to take a look at what exactly are quadratics. So our first look is going to be at the expression itself, and hopefully by the end of today's session, you'll be able to identify the general form of a quadratic expression. You should be able to justify giving with valid reasons why you are classifying any expression as a quadratic versus those which are not. So for those of us who have trouble with visualizing a quadratic, I'd strongly suggest developing something like algebra tiles to help with being able to understand what a quadratic expression looks like in terms of having something physical to play with. So creating algebra tiles and using these algebra tiles to represent some sort of quadratic expression will also help you with being able to at least visualize what a quadratic expression looks like. So let's get started with our objectives. The very first thing we're going to look at is the first point, which is being able to identify the general form of a quadratic expression. Now, before we jump into the general form, it's important to know that there are different types of algebraic expressions. Some you are familiar with, some you aren't. And if we look carefully at all these expressions, they are algebraic, but there are some of them that are pretty much distinguishable. You can see in some of the expressions there's a little difference, not just in terms of, how many terms are there, but also in terms of the variables, in terms of indices. So when we look at algebraic expressions and we want to start talking about classifying a quadratic, a lot of things that we need to pay attention to starts from things like variables and indices and the terms in the expression. Our general quadratic expression usually is given as what we refer to as a trinomial, where it contains a variable raised to the power of 2. Whenever we're dealing with a general quadratic, we are always looking for an expression that contains at least one variable that is raised to the power of 2. And particularly when we deal with quadratics, we want to ensure that in this expression we don't have things like cross products of different variables. We don't want to have cross products of different variables raised to different powers. So a quadratic expression, in essence, must always have a variable that is raised to the power of 2. And if it contains any other variables, all those terms that contain those other variables must not exceed the power of 2. So our general quadratic expression, ax squared plus bx plus c, this is what you look for when you're looking for a quadratic. And if we just, take a little glance at the slide from before, we can see that there are several expressions here where you can notice there's a term that actually matches up to the quadratic expression, that first term where we have a variable being raised to the power of 2. You might have noticed numerous expressions here with that particular condition. Now, we said that the general quadratic is of the form ax squared plus bx plus c. And oftentimes, students assume that a quadratic expression will only come in this form with the variable x, but it can also come with a variety of other variables. Now, as you can see, there are some expressions here with different variables, not just x. So this is just to highlight the fact that you can have quadratic expressions, but they don't necessarily only have to come in x. They can be in terms of variables like, as you see here, m and y. Now, if I want to be able to identify a quadratic expression, like I said, the first thing I'm going to look at the expression for is whether or not it has a variable raised to the power of 2. So I want you to take a look at all the expressions that we have here. Can you identify expressions where you see this particular condition? We can start by looking at the ones that we know match the exact criteria of our general quadratic expression. So if I take a look over here, I can see this particular expression matches up to the exact quadratic expression that I've just looked at, and it is a trinomial, right? It contains 3 algebraic terms in this expression, and it has a variable raised to the power of 2, and as you can see, it's the only variable in the expression, and there is no other term involving a variable that is raised to a power that is higher than 2. There is no cross product of variables. So this particular expression here satisfies my conditions for the expression to be quadratic. And again, there's also this second expression here. The second expression still follows the same exact format of what a general quadratic expression would look like. It's just that we're using the variable y. Now you might look across here and you might notice we have an expression 2x squared. We also have x squared minus 9. While these don't have the full trinomial form, these are still quadratic, simply because they contain that term, that algebraic term. Notice that they have a variable raised to the power of 2, and this is what makes it quadratic. So regardless of it being trinomial or not, the important condition for any expression to be classified as a quadratic, there must be a term containing a variable raised to the power of 2, and that must be the highest power in the entire expression. We've identified the algebraic expressions which are quadratic. Now you might take a look at the entire slide again and see, but what about this one? There's a reason why we cannot classify this particular algebraic expression as a quadratic. And although we see that x is being raised to the power of 2, what we have here is what we call a cross product of variables. So I have x squared times y. Having this particular cross product of variables is what prevents me from classifying it as a quadratic expression. Because when I deal with a quadratic expression, I cannot have a cross product of variables like I do here. Once you are clear about when you can classify an expression as a quadratic, you'll have no trouble with being able to choose all the algebraic expressions you find around you and classify them as quadratic or not quadratic. Now there are some other things that we need to know about when we work with quadratics, and one of those things would be the terms involved in the quadratic expression. There are specific values that we need to be able to identify, and for this we are going to move back to our general quadratic expression. Now notice here our quadratic expression ax squared plus bx plus c. I've identified a, b, and c. In mathematics, when we want to give something general, we don't use just random numbers. We actually use some letters that we will typically use as arbitrary constants. And when we use these letters, it means that these particular placeholders can take on any value. So for instance, here in the general quadratic, we have a, b, and c. While we have a, b, and c, and you might think, well, what are those things supposed to represent? They can take on the value of absolutely any number. And I want you to pay attention to the statement at the bottom here. This statement says A, B, and C belong to this set of real numbers. So whenever we are looking at a quadratic expression, we want to be able to identify certain parts of the quadratic. We pay close attention to the coefficients and the constant, which, like I said, can take on absolutely any numerical value, and that will form a quadratic expression for us. So this is where that skill of being able to use algebra tiles to create an algebraic expression that is quadratic will come in. Alright, so let me demonstrate with the algebra tiles that I have on hand. When we use algebra tiles, we need to remember that the expression that we're constructing will consist of the various tiles, and all we have to do to get the expression is write down the number of times that we see a specific tile occurring. So as you'll notice with the examples that I have here, that when we construct any quadratic expression using algebraic tiles, essentially what we're doing is creating like a rectangular shape. But here for the demonstration, I simply wanted to show you all how you can use the tiles to create a quadratic expression. And one of the things we have to do is simply count the tiles, count how many of each type you see, and that's your quadratic. Okay, so now that we know how to identify a quadratic expression and we know how to establish a quadratic expression using algebra tiles, let's talk about the coefficients and the constant. When we look at a quadratic, we want to be able to identify A, B, and C. So here we have two quadratic expressions, and one of the things that happens pretty often is that students have a challenge with being able to identify the values of A, B, and C at times, partially due to challenges with algebraic expressions themselves, and also due to their issues with directed numbers. So we're going to take a look at these two specific expressions here, and we're going to learn to identify the values of A, B, and C in this particular scenario. So let's start off with the very first one that we have on the left here. We have x squared minus 3x plus 4. So one of the biggest issues that crops up often with students being able to identify the coefficient of x squared in expressions like these, they don't see the coefficients. You're not seeing a coefficient here, and automatically a student will process this as 0. However, what you need to understand with algebra, this ties right back to your basics, okay? And the reason we don't write the one, it's understood. If you just have an x squared, you have an x squared, okay? So this is something that usually, like I said, it can be confusing to students. They can make a lot of mistakes here, and they might think the coefficient is 0, but in fact the coefficient is 1. So whenever you see a variable standing by itself, and in this case x squared by itself, no, it is not 0x squared. If it was 0x squared, you wouldn't have x squared at all, okay? 0 times x squared is 0, because anything times 0 is 0, and that's something that people don't really fully comprehend. So remember, whenever you're doing identification of coefficients, I want you to pay close attention to that. Alright? You cannot have a coefficient of 0. If you had a coefficient of 0, you wouldn't have the term. So I'm just rewriting the quadratic expression above here, ax squared plus bx plus c, just to remind ourselves about our general quadratics so that we'll be able to easily identify what we're looking for when we talk about the values of A, B, and C. The coefficient of x squared, as we just discussed, is A, so A will have a value of 1, not 0. And we know why this is the case. Now, here's something that confuses many a student. When you have plus bx in your quadratic expression, and then you come to an expression that has a minus 3, students might start thinking, but this positive and this negative, so I just need the number. I want you all to understand as well that in a general expression, especially in the case of the general quadratic, we just use plus. We just use that positive. We don't put the negative symbol in there, and it does not necessarily mean that the constant b cannot take a negative value. It's a numerical value still, and all quadratics, regardless of the values of a, b, and c, they would still be valid quadratics as long as the number is a real number. So here, when we look at identifying the coefficient of x, the value of b would be -3. And then if I want to find the value of c, my final term in the expression is my constant. So this is how I know that c is +4, and I want you also to notice that I am stating the value with the sign. Now I need to further digress a bit, because some of the common errors that I've seen with being able to recognize a, b, and c come from challenges with being able to distinguish between coefficient and variables. Whenever we deal with a quadratic expression, you need to remember the quadratic expression has a variable that's raised to the power of 2, as we see here, and then there might also be another term that is included with a variable. Once you can recognize what a variable is, when we talk about a, b, and c, we're just talking about a numerical value. We're not asking for the variable being attached to it, because some of the things that we do see as well popping up pretty often, and they may do things like state in this particular example that a is x squared and that b is -3x, but this is not the case. Remember, your coefficients refer to the number that is in front of the variable, alright? And that's the reason why I wrote over the quadratic expression above, so that you can do the comparison, right? And even if the expression didn't have x in it, once it has a variable, remember, the things that we're concerned with would be the numerical values, not the variables. So this is the reason why these things are incorrect. Okay? These are incorrect. So make sure you can distinguish between coefficient, constant, variable. These things are extremely important when you need to be able to identify a, b, and c for a quadratic. Now, let's talk about the second expression, and I'm sure you can easily identify a, b, and c. Okay, so a, b, and c, here we have a as -3, b is +2, so this one, no big sats of trouble, right? And c is also positive, c is +5. We want to take a look at these 6 expressions, and your task is to compare the 2 sets of expressions and identify whether or not the expression is quadratic. So this is testing your understanding of a quadratic expression, that general form, being able to recognize it, and it's testing your ability to give that logic, use that logical reasoning as to whether or not an expression falls under the category of quadratics. So let's take a look. Beginning on the left hand side, we have y squared -4. We need to compare y squared -4 with y -4. Which do you think is the quadratic? And if you say y squared -4 is a quadratic, excellent, because this is the expression between the two. This is the expression that has a variable raised to the power of 2. And although it's not full trinomial form, it still in fact contains a quadratic form. Let's take a comparison of the next 2 expressions. We have a ½ squared -3x and 3x cubed. Okay, so I think this one is going to be pretty straightforward, because immediately when we look at 3x cubed, we can tell that x is raised to the power of 3. And we said that in a quadratic expression, the highest power of any variable should be what? It should be 2. So for this reason, this is not the quadratic, but this one is the quadratic, alright? So a ½ squared -3x is the quadratic. Alright, so the final 2 expressions, let's take a look at them. and it might be a little bit tricky, but I want you to pay attention to the variables and terms in the expressions, and immediately we can rule out the one on the left. Isn't that so? Can we rule out the one on the left? And if you said yes, you can, because if you look carefully here, look at this, although we see the variables being raised to the power of 2, do you notice that we have cross products of variables? This is not quadratic, okay? This one is. So we've identified our 3 expressions in these 6 expressions here, the ones that are quadratic, and we have used our understanding of quadratic expressions. We can logically validate which expressions are in fact quadratic and those which are not, right? So that helps us wrap up what we aim to do in today's session. So before we go, just make sure that you can do each of the following, right? We did start off by seeing what our objectives are. Here are the objectives yet again. Take a look at them. So can you identify the general form of a quadratic expression? Think about it. Write it down. What is the general form of a quadratic expression? How did you do on our last little wrap-up exercise there? Were you able to identify all 3 quadratic expressions easily and was able to justify your choice of which expression was quadratic? Because if you were able to do that with ease and you got all 3 correct, you can definitely justify giving with valid reasons expressions which are quadratic and those which are not. You have 2 objectives completed, and if you were able to follow along with the algebra tiles and understand how to establish a quadratic expression, you identified the form of the quadratic expression. So at the end of this session, I hope you fully understand how to identify a quadratic expression and you feel very confident in your abilities to work with quadratics, because once you master this particular skill, the rest of quadratics should be just fine. It will just be testing some more of your algebraic skills. So, did you enjoy this particular session? If you did, be sure to leave a thumbs up and share with your friends as you guys prepare to write CXC exams. Be sure to tune in for future videos as we continue our Masterclass series in quadratics. Thanks for watching.